Okay. So on the back of our notes, we are comparing or ordering our scientific notation notes. So you guys have compared numbers before, okay, with the greater than, less than, equal to symbols. All right. So remember, the alligator always eats the biggest one. Okay. So when we have scientific notation and we are wanting to compare, the first thing we have to compare are those exponents. So first thing is we compare the exponents. So always look at the exponents first because they tell us a lot of information. So guys, what do you know? If something's raised to, like, if you have 4 to the 5th power and 4 to the 50th power, which one's going to be bigger? 4 to the 50th power, because that exponent's bigger, right? So guys, the greater the exponent, the greater that scientific notation is going to be. Okay, so the greater that exponent is, the greater that scientific notation is going to be. Because again, 4 to the 5th is going to be a lot less than 4, no, not a 4. 4 to the 50th, there we go. Okay, the exponent's bigger, so that number is going to be a lot bigger. Okay, sometimes our exponents might be the same. Okay, they might be the same. So if our exponents are equal, and only if they're equal, then we have to compare the decimals, or the number out front, okay? Then we'd have to compare the decimals or the number out front. So let's say I have 3 squared versus 4 squared. Well, don't these both have the same exponent? Yeah, so that's going to be similar. That's going to be the same. But y'all, which number is bigger, 3 or 4? 4. So what's going to be bigger, 3 squared or 4 squared? 4 squared. So again, our alligator would eat this bigger one here because, 4 squared, love it. Because the base or this decimal out front is bigger. So the greater the decimal, again, the greater the scientific notation. Okay, y'all got this down? Y'all paying attention? Okay. Yep.
So we don't do this as exponents are equal, but like, what if there's an exponent that's 100 and like 1, and then there's an exponent that's like 2 and 2. Like the exponent's 2, and then there's 100 and 100 as one exponent. 100 is going to be bigger.
That's such a good explanation.
And what if it's 2 instead of 100?
Compare exponents first, I promise.
No, but like, alright, so if there's 100 with one exponent.
We'll look at it in a minute, okay? Let's get through our notes, okay? Let's get through our notes first, okay? And then I'll get y'all's questions. So look at number 1. Okay, we have 2.35 times 10 to the negative 5th, 1.49 times 10 to the negative 2nd power. Now, when we have negative exponents, I kind of lose some people here, okay? So first of all, we are going to compare, step 1, compare exponents. Are these two exponents equal?
No.
No. But we've got to figure out which one's bigger, negative 5 or negative 2.
Negative 2.
Oh, y'all are so good. Oh, you're so good. It's closer to the 0. Very good. Okay, I am going to draw a number line because some of y'all totally got that. I've never had kids just know. That's amazing. I love y'all, okay? I know. I tell y'all every day how much I love you guys. I can't help it. Okay. So, I want y'all to draw the number line just to remember, okay? But y'all don't have to do this every problem if you know it, okay? So, if we have negative 5 and negative 2, negative 2 is closer to 0, and then negative 5 is way back here. Okay, so I know sometimes we're like, 5's the bigger number, so it's greater. But negative 2 is further right on the number line. And the further right you are, the bigger you are on a number line. Okay? So therefore, what does the alligator want to eat? That one with a negative 2 exponent. Very good, guys. So that means this is less than this one. Very good. Y'all, I'm so impressed. I know, y'all get this every day from me. Most days. Some days y'all sit here and breathe. Y'all don't get praised. Alright, number 2, compare their exponents. What do you notice? They're equal. Okay, so if our exponents are equal, then we have to do step 2 and compare the decimals. Yes. You know which one it is. Which one?
It's 3.
The one on the right? The 9? So we want to eat the 9?
Yes, because the 3 is a lesser number.
3 is less than 9, so the alligator wants to eat the 9.
Whee!
Okay? And I know, just to explain this right here would be point 1, 2, 3, 4, 5, 6, 7, 8, 3, 4, 3, 4. This one would be point 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 4. They're going to have the same amount of decimals, so that's why we can compare this. The negative 9 means they're going to have the same amount, or same amount of 0, sorry. And so, you know, what's going to be bigger, 0.3 or 0.9, something like that. Okay? 9's bigger, so our alligator wants to eat the 9. This is less than this.
I don't
Yes.
mind just because
Like, I have a, like, can I go up there to the board and show you? Because I don't know how to say it. It's real quick.
Not right now.
Look, couldn't you have just put that line over it?
What?
Oh, I got it because like 9 had less numbers. It's just the same exponent. I just saw that.
What do you mean less numbers?
It had less numbers for the multiplication because
Okay, what if this was 3 times negative 9, 10 times to the negative 9th, and this was 9 times 10 to the negative 9th? Which one? It's still 9, right? Okay, so it's not about how many numbers are behind the decimal. It's about what the what the front number is. Okay? Okay, good. All right. So at our bottom of our notes, okay, if we can compare numbers, then we can order our numbers. All right? So we've got to know, first of all, ascending means what?
ascending. It's
it's going up.
Going up. So that means we start with the what to what?
Left to right. Right to
right
left.
to it. Left.
Half the box.
Y'all aren't quite following me on that one. Smallest to biggest. Very good. Smallest to biggest or least to greatest. If y'all like smallest to biggest, y'all can do that first. Or two. Smallest
Biggest even a word?
to
Yes.
biggest.
Yeah, the biggest turtle is.
Don't lose your sticker. Okay, least to greatest or smallest to biggest. So we're starting with the small, we're going to the big. Whereas descending means we're going
Greatest
to
to least.
greatest to least.
I knew that because like decrease, descend.
Yeah. Or big to small.
Way small.
Okay, biggest to smallest. Okay. Alrighty. So number three says we want to put the following numbers in what order? Ascending. Ascending. So ascending means small to big, right?
Yep.
So I'm actually gonna write small over here and big over here. Because sometimes I forget whatever I'm actually comparing numbers, what I'm doing. Okay, so I'm gonna do small to big. So in order to compare these, what do I need to look at first? Those exponents, okay? So I'm gonna highlight all mine to look at them. So I have a 3, a 15, and a 3. Well, which one's different than the others?
15.
The 15. And guys, is this 15 the small or big?
Big.
The big. So where would I want to put that?
Big back.
The back. Okay, so I'm just going to go ahead and write that because that one I definitely know is the biggest number. And if we're writing in ascending order, I want to write small to big. So the big one's going to go in the back. Okay? Now I've got to figure out which one's the smallest, which one's the middle one. Okay? So now we're comparing these two right here. They have the same exponent of 3. And since they have the same exponent, that means I've got to look at their decimals. So 7.4 compared with 4.53. So Tariq, which one's bigger?
The one on the far. The one on the left.
The one on the left is bigger, right?
Yes.
So is that going to go in the small space or the middle space?
Right in the middle.
Right in the middle. Very good. 7.4 times 10 to the third power.
Oh, you're supposed to put that.
What were you doing? I got to put the whole number. What were you putting?
The whole number on the side.
Okay? And that means if this number has a 3 and it's 4 is smaller than 7, it's going to be the smallest, so it's going to go first. So 4.53 times 10 to the third. And again, we can see our exponents are 3, 3, 15, so small, small, big. And then 4 is smaller than 7. So I can see that I did. I put these in ascending order from least to greatest. Dylan.
Can I please do the next one?
Dylan. Honey, chill.
Show you my skills.
I'm very proud you have skills. I really am. Okay. Put the following numbers in, this time, descending order. Okay, so descending means greatest to least or big to small. And I like to write this out because I forget sometimes. I get confused, so I like to write big first, small in the back so I can remember. And I know y'all are going to get this because y'all understand your negatives, don't you? So, looking at our exponents first, I've got -5, -12, -5. I'm going to draw my number line again just so I can see. If I have 0, what's closer, -5 or -12? -5 is closer, -12 is further away. It's further left. So, is -12 going to be the biggest or the smallest? Y'all are so good. It's the smallest. -12 is, hang on, chill, deep breath. -12 is further left, so it's going to be the smallest number. So 8.5 times 10 to the -12 power is going to go over here. Okay. Now, we have 2 with the -5 as our exponent, so we've got to look at their decimal. So, Dylan, which one's biggest, 2.4 or 2.5?
Since -12 would be 2.4 because
I got it, I know the right answer. No.
Dylan, please stop tapping.
Wait, what did you say? Which one's what?
Dylan, I said which one's bigger, 2.4, 2.5? $2.40 or $2.50? 2.5 is bigger, right? So if this is bigger, does it go first or in the middle? First, because we wanted to write from big to small. 2.5 is bigger than 2.4. So 2.53 times 10 to the negative, that's a 5. And 2.4579 times 10 to the -5. So again, descending means big to small. We have -5, -5, -12. -12 is more negative, so it's smaller. And then 2.5 is bigger than 2.4. Okay? Y'all feel good about this? Awesome job.
Do your homework now.
We're about to get started.